Okay, so it looks like we're live now. Except for Twitch. So I'll let that buffer a little bit more before I begin. This is going to be a bit of a quieter, more of a get work done type of presentation today. Which is perfectly fine. Alright. Whoops. Where are we? Social. New page. Q&A&Critique. Control-Shift-V. Alright, so those of you who are here, thanks Pancakes for connecting, and also for Marcel Caban. I'm glad to have you here today. So today's is session number 30, which is an interesting one concerning longevity. I never expected to do 30 of these. So today we're going to be exploring a little bit more of the project concerning building a city for the Painterly project. So to build a city for the Painterly project, we need three things: scattering around the city building blocks around the city and with some control. Some way of procedurally generating the buildings to make them unique, and also roads and bridges and things like that, because it's a futuristic city, which means it's a multi-layered kind of hive of development and industrialization. These are done with my Painterly props that I've been working on this week. So let's take a quick look. And bonus topic that we're going to take a look at today is also using the raycast scattering technique to decorate the buildings with some randomization and control. So without further ado, let me show you my Painterly building assets that I have, which was a blend file, cc by. The assets were created, let me just confirm. These assets, you can cc by and cco assets are quite useful for saving time, and I've been using them as base meshes for creating everything else. So let me just confirm. Architecture, modular air dug bolt, maybe it's in my city kitbash architecture. Sci-fi buildings pack by who? Oh, I didn't cc by. Oh man. Oh well. But I think you can find them blend swap. So these buildings here are practically, or Gumroad actually. Yeah, that's where they are. So I just practically, what I did is with my add-on that I created and these buildings, I use a remesh modifier, apply it, then I displace it and weld the geometry to kind of like remesh the really hard surface cyberpunk type of models into my soft curvy models. Then paint on the 4 vertex color groups onto each of the buildings so that I can use them to kind of paint in my brush effects into the actual model. And then I'm using my vertex color painting to kind of give them some colors based on the color palette that I designed earlier. What we're going to do is we're going to create these buildings scattering around onto geometry with some control. Basic stuff. After that, we have some like more smaller pieces of stuff that we can use to decorate the buildings, decorate the streets. We got air conditioners, we got just random pieces of chunks, antennas, different things like that. And we can use that to kind of scatter, I could say, these decorations onto the actual, as you can see here. I can use a grid pattern, or I can use a random Poisson disk to scatter the raycast onto the actual geometry however I want, up close to the camera or not, without needing to scatter absolutely everything to save on RAM and render time. So without further ado, let's start with the basics. But before that, let's start with a little bit of a geometrical generation of these buildings. So first things first, we need to go back to the source. So we have a new person here. Hey, bored human, how you doing? Oh man. Okay, so in this particular scene, this is what we have, but in another scene that I've been working on, let me just throw that video up. If you have been paying attention from last week, I started creating some renders from the actual Painterly effect. So the way these the Painterly effect started rendering out, it gave me a lot of ideas, but a lot of things to think about. So for example, here in this video, which I'm going to upload into the chat, you can see I have kind of like this style going on with some brushstrokes, silhouette, my sky system. I kind of created some lights with some volumetrics, some neon lights, which is exactly what I needed for the actual project. And I've been testing the Painterly effect with animation. I kind of like the 12 frames per second. I might increase it a little bit, maybe to 15. But I have my Painterly effect now, more or less. So now I'm just creating the city. So from there, okay, so we have to go back to the reference and we got to go back to the city. And so I loaded up Pureware and I have two cities that I'm basing myself on. One of them is my home city, which is Bogota in South America, which is a very metropolitan city. Like this is downtown with a lot of architecture from the 80s and the 60s that there was a big boom. But just recently, the city has actually started to add in a lot of like cable cars, and in the south part of the city, there's a lot of lower class type of architecture, and the architecture is very boxy. If you like, and on the hills as well. So the lower class actually takes the hills, and the higher class takes the lower parts of the city. So these boxes are very kind of irregular. There are cables everywhere. If you take a look here, there are power lines everywhere. And everything's stepped, kind of like a falabella from Brazil to some degree. Stairs, things like that. And the other city is Toronto, which is, I think, the hometown of my client. The key aspects that I like from Toronto is these waterfronts into the lake. Tracks, waterfronts that kind of like reclaimed land into the lakes, right beside these skyscrapers and buildings, Art Deco, which came in from the 30s and things like that, mixed in with a very modern 90s aesthetic. So there's my, the interesting thing about Bogota though, is that there's mountains to one side, which are really beautiful. And then there's like the towers and the buildings and the highways and things. And the good, and which brings in the central part of the city, kind of like Hong Kong, I guess you could say. But these mountains are huge, a lot bigger than the ones in Hong Kong. But then you have a sprawling city. Meanwhile, here in Toronto, even though it's a very large city, it's very sparse. There's a lot of parks, a lot of trees, a lot of things that we need to look at. So what we're going to do is we're going to try and mix and match the two concepts together to build the cities. The good thing I do like about Toronto though is that you have some very iconic skyscrapers and a very dense, tall downtown, which is right by the waterfront. So my concept here, we're going to have to kind of create this cluster system, and then we're going to have to create kind of like the suburb system, and then think of like maybe do some manual construction for the waterfront system or the industrial area, and also create these highway systems. So let's start, I suppose. First things first, building clusters. So we have two types of clusters. One is the tower cluster, and the other one is the general building generator clusters, along with power lines and things. So cables, I'm still not versed in it very well, but we can make the downtown cluster quite easily. So let's start there. We're going to use a guide mesh first, and we'll get into the software and start immediately. Make it nice and big. Go into my nodes, make a new tree, zoom into it. Here it is. So first things first, we need to use instances. Instances on points or scatter points on faces. So we have two groups. One is the instances group and the other is the points group. So if we use distribute points on faces, this will give us random and Poisson disk, which can be good for organic stuff, or we can use a grid system. So if we use the instances on points, that means we can like define what kind of points we want to create the type of setup. So if we use a mesh primitive which has a grid, we can use the grid as the actual points on the actual geometry, and define the size and things like that, and the length and things. So let's just drive this out onto the size and the vertices. Just two attributes from the group input, and we're going to use a collection. We go to the input collection info node, and we can select our collection with the buildings. So these are hero buildings. Just grab them. I'm going to separate the children and throw them into the instance. Basic scattering with the grid. Now if we zoom out a bit, take a look. Whoa. Everything's absolutely massive. Hang on, let me just make sure my view is correct. View. Let's give me 10 kilometers starting at 1. There it is. Now I can see maybe a bit more. 100 kilometers. And there we go. In this case, we notice that every single point is instancing all of the buildings, which is a really big performance hit right now. So what we want to do is we want to turn on pick instances so that every single point has just one instance of that particular mesh. So now, if we reset the scale, there we go. We have this grid, and we can change the size of the grid and how many vertices that we have on the grid to kind of get an idea of what we're doing with the points. So notice if we turn on or off, okay, so let's just use a join. Where's my search button? Search, assign shortcut. So join geometry. I want to just see the grid right now. So here's the grid. If we go into wireframe mode, this is the grid. We change the, as you can see, here are the spaces or the points on the grid. And there's the size, the particular size. So now if we go into join geometry along with the grid, there's something nice and simple. Things feel a bit off for some reason. So if we take a closer look, this is now we got to start doing some troubleshooting, and this is probably because these are not in the center of the world. So I'm going to get all the hero buildings and reset the location to the center of the world, and then I'm just hide them. Hello everyone. Oh, we got J-Bar here and Kurumao. Thanks for joining. Hello J-Bar. How have you been? So right now we're currently looking at using points from a grid to drive instances on points. And we're going to use Oops. Original. There we go. And we're just getting the location of the buildings, but right now we are instancing way too many buildings because we're not using separate children. Reset the children. Pick an instance. Instance on points. Here's the grid. That's strange. Let's try something else. Distribute points on surface. I'm going to just use the basic grid. Points on random. Let's see. Whoa, it's running really slow right now. That's because it's got way too many things. What is happening? Okay, I'm going to disable the tree for a moment and see what is my setup concerning the instances, because maybe I'm instancing on myself and it's doing a recursive loop without me wanting it to. Good lord, I crashed. Damn. This is where you make a video where you edit out the crashes. End process, thank you. Done. Let's try that again. And are we back in business yet? Almost. If you guys had a look at this image that I have here, I was using SRT randomization with geometry nodes, which is pretty easy. Let's go back to the building pack and I'll show you how to do it with this when it works. Oh, you did? You finished the fridge for the game. Oh, good. I made a... Yeah, the fridge looks great. I like the blue fridge. Though the red fridge for the Christmas theme looks best. Okay, so what I'm working on today is basically city generation using geometry nodes. That's basically it, really. I'm gonna make a new, just use this plane, just make sure it is in the correct, call this GN, Reg Bridge, Raycaster, supports, scaffold, cables, and we'll call this city block. City block. So I'm going to create a new collection called city block instance. And that's all we need. So this is going to be my emitter. And this is going to have my geometry node tree. Back into nodes. Okay, cool. And let's just make this random. So move this over to the side here. Take a look at my hero buildings and hide everything else. So here are my hero buildings that I'm going to take a look at. They're really big, absolutely massive because they're skyscrapers. And I'm going to be using them as my basis for the scattering. I'm just going to link them into the instance collection here. But to do that, I'll just drag and hold down Control to link inside the collection. This is my instance collection. And if I don't want to use all of them, I can just unlink, Control, Shift Select, and unlink some of them from that collection. They're still in the original collection, but now they're actually in my instance collection with only 5 or so instances. Let's go back to my city block piece and make a new tree. let's go back to the beginning. So first things first, it's good to use just the little basic curve geometry primitives instead of the actual instance. I'm going to instance on points. I'm going to use a mesh primitive. We're going to use a grid as my points so that I have some control of the city grid. And then I'm going to use basically a cube just to start as my instance. And here it is. So now in my settings, I want its output to my size to the same and my vertices to the same, so that in my geometry stack it's just the one and the same. And there we go. So I'm going to just draw the grid with the join geometry output, which is underneath the geometry operators, join geometry. And I'll just connect the bottom grid. So here we go. We're good. And now we have basic movement, I suppose. So let's go back to, let's get a vector node. Vector combine XYZ. And then I'm going to use two value nodes, which I need to add a hotkey, Shift A, whoops, remove the shortcut, Shift A, assign shortcut, yeah. Hold space, I like this. So I get a value node, and I'm going to put this to 1, put this into the X and Y so that they scale both in the same size, make another value node, put that into Z, and the Z I'm going to use another combined RGB so that the Z movement of the actual transformation of the points moves up as well. So I'm just going to get a transform instances node, and I'm going to plug in the combine Z into the transform instances node. So when I move things up, oops, I need to subtract itself, because this is where the issue happens with the center of the cubes, right? The center of the cube is here, but it starts from the bottom here. So I need to, when I scale the cube up, it needs to be divided into 2. So we got to get a math node. And we'll just multiply it by half, so that when I scale it up, the position is halved, because right now when you're doing the Z is kind of like, okay, I want the Z to be 1 and 1. So this is a 2-meter cube. So the center of the cube goes 1 positive, 1 negative. The origin is floating at 1 from the surface. So 1 plus 1 is 2 for the size, positive and negative as a scale. So the position needs to be half of the height so that it moves up like half the height, or it kind of offsets itself by half so that it kind of looks like it's stuck in the same place. So that's how you would scale some cubes like that, nice and easy, by moving by half of the height on the scale. So now we have this, and with these two controls we got as many vertices as we want for the city blocks, and we have as many pieces of things that we want. So that's kind of nice. These could be used for my city blocks. So what I'm going to do is I'm going to keep these cubes here for now. I'm going to create another grid, and this grid is going to be instanced onto the other points. So I'm kind of instancing points on points to create blocks so that I can have multiple buildings on the one block. Oh, hey James, nice to meet you. So let's do this. So we got a grid. Let's just go into wireframe so you can see what's happening. We've got these grids here, the grid on the ground, instancing the cubes. So instead of the cube, and we're just going to mute this for now, which would be the M key, mute. I'm going to instance a grid on a grid. So here we go, we've got a grid on a grid, beautiful. And I'm going to disconnect this offset for the cubes for now. And I'm just going to move it up a tiny bit so that we don't get so much zeta depth, zeta clip, I guess. Move it down a bit. And now we have a different, we've got the street cluster. And now we have, if we get another value node, we've got the blocks. So these blocks, I'm going to use these blocks as my instance to instance more instances. So let's get another instance node, instance on points. Plug it in after, and we're going to use the same cubes that we had earlier. And we're going to, oh, it's probably have to put this after the translation. There we go. Move this, get another translate instances, move this over here. And this is my cube setup. So I'll tell you what, let's go full screen so you guys can see closer. Let's just put this in. We'll call this my cube instance viewer. So the Noodler add-on I highly recommend because you can have color palettes onto your nodes. So this could be kind of like my viewer node, so I make it nice and red. And you can have these input values as a green to kind of show you what you want. So this would be the height, and this here would be the size, general size, XY size. This cube is now my new instance. Boom. And I'm going to multiply the translation here by half so that now I have some control of the towers per block. So let's just make sure I'm seeing everything correctly. If we take a closer look here, we've got the blocks. As you can see, a block of buildings here. So we got some streets, or some spaces for streets, and then we have another grid which we can use to kind of create the building blocks. So that's kind of nice. All right, so now you have a question. Oh, I have a question. How do we randomize these attributes for the city blocks and things like that? Because we could do this for with a grid or another base mesh. Like for another example, if I create a base mesh to create the city center, which could be this. If we go back and apply the modifier stack, if this is my city center and I kind of deform it a little bit, you know, just kind of like make some interesting shapes of a block like this. If I use this as my base mesh, I still need to randomize some things. So let's move it over here. And we've got this here. So instead of using a grid, I guess we could use an object. So let's just freeze this tree and grab this plane that we're using. Get the object info, which has a geometry output. And in this case, we're going to just grab it. And now we just have a separate mesh, I guess you could say. So I guess we need to scale the object a little bit or transform it. So let's just take a look at my add nodes and just see what we have for transformation. Rotate scale instances, that's per point. We have mesh primitives, we have texture point, output text, utilities. Rotate math, nope. Whoops, vector. I keep forgetting. Search. So for scale instances, transform. I guess we have to do it within the object, we'll just use relative. So now that it's relative, it's based on the original object. Here we go. There we go, we got our city blocks based on the certain points of our guide mesh. So if I wanted to like create a new block here, whoops, I can just create 2 blocks here and I have 2 more buildings. Or if I want like another block here, I can draw this and hit and draw a line and create another 2 blocks there. Now I can change the density or the design, I guess you could say, of how I want to create the mesh, and also later on just sculpt it or edit it to kind of get an idea of where my positions of the blocks are to kind of create my city with some artistic direction. Okay, cool. But all the streets are perpendicular. We need a little bit of randomization. These towers look super uniform. So we need to go back into our geometry node tree, back to the grid to keep it nice and simple. So here's the grid. And now we need to like just do a little bit of randomization. So let's just organize this tree just to make it nice and simple again. We have the instance that blocks onto the guide mesh. This is what we're working on. And I'm going to call make it nice and orange. Step number 1. This is this here is my, I guess you could say, the block instance. So I got a question for you guys. To randomize the position of these city blocks, I guess you could say, would you guys prefer to randomize the buildings or randomize the actual blocks? And if that's the case, if it's going to be for the blocks or for the buildings, do we do it after or before? What do you guys think? And also, hello, Aaron. Grid cities. Try and generate UK city, yeah. That's why I'm kind of like trying to create some systems. My references for the cities that I'm kind of looking at is Toronto, which is very much a grid city, and Bogota, which is another. It's got some grids going on inside of a fractal concept, but generally the blocks are pretty boxy. Everything's very boxy. So I'm just gonna like create a general grid, I suppose, which I can draw around what I need, and then I'll just randomly instance the city stuff that I need. I'm currently trying to create a system for clustering the city center for now. And after that, I'm gonna work on some highways and other things like that. So let's randomize these buildings. Hello, Arturo. Arthur Frias. And Wittenen, nice, and Yush. Alright, we got some heavy hitters in here today, so don't take my word for it when it comes to geometry nodes. Say that again?
Good job, you can do it.
You're a little bit quiet, but welcome, Wittenen. Okay, I turned you up so I can hear you now. So how you been, Wittenen?
Fine. Just busy with a lot of stuff at work and
A lot of stuff. Yeah, you have you created the Christmas tree that was released for free recently, correct?
Yeah, that was like a really quick project. I wanted to give for free, so I didn't spend so much time on it.
Oh, it's an excellent Christmas tree. I really liked it. I haven't picked it to pieces yet, but I think it's got some really cool techniques going on in there.
Yeah, it would have needed some adjustments, so the decoration would have worked better when you adjust the length of the branches, but it is what it is.
It is what it is. But you did a good job.
Thanks.
Alright. So now I'm gonna get a... So have you made cities before, Wittenen?
I've tried few times, but I think there's not enough tools to make like a proper one yet, like the streets connecting and...
Yeah, I'm gonna have to do a lot of artistic creation, so I'm just creating kind of like modular tools right now.
The grid is usually the only thing that works at the moment. Because, for example, you can't merge the paths that could make some crossroads. And
That's true, yeah. I'm gonna have to like kind of wing it from the camera, I suppose. So, the way I've kind of split up my tools is basically I need to create a system to randomize building generation. So this is separate. And then I'm going to use another system to scatter around some guide geometry to kind of build the city from the ground up to however I want. So for example, if I want downtown over there, I can have it. The next thing is just create some artistic curves and instances to create my highways and bridges with the painterly effect. Because earlier, like, well, this is my painterly effect that I've been working on. Now I just need to create the city pretty much based on that effect. And obviously I need to tune everything. But so now I'm just going to create, I'm working on the city block generator. So to do that, I need to have some scaling, some random scaling of stuff. So I'm going to get a random value. But why is it not scaling every single thing of points? Okay, it's doing it per block. Okay. Okay, so each block I can change with a seed now. But what about every single point on the seed? Welcome to Africa, the noodler city. Wow, a lot of cul-de-sacs and everything. Look at that. And also London, it's a radial city. Partially grid. It's incredible. Yeah, my city is a pure grid, pretty much. Like, it's very hard to get lost here because it's all based on it's like battleships where you have up, like north and south, east and west, do the crosswork and you find your way. And there's some key highways in between it all. My city's pretty grid-like, which a lot of South American cities are actually. And Toronto as well is very grid-like. Alright, so is there a car culture in South America? Only in the higher class. In fact, Bogota has the most amount of cycleways of any other South American country. Believe it or not. A lot of people cycle. It doesn't have a metro system though, which is crazy. It has this bus on lanes with stations system, which is like a cheap version of the metro. And double jointed buses. I think Bogota was one of the first to implement that system. It moves about 1 million people per day. So it's kind of efficient. But then again, the city's about 9 million people large. Okay, so back to work. But if you guys want to open up your microphone, feel free. I mean, there's no... I know this country is basically a Voronoi texture. I think the grid concept is actually coming up from colonial city era design. So the older the city, the more likely there's going to be a grid. Okay, so question for you guys. This is kind of like a pop quiz. I'm trying to create this concept of I have to randomize each of the buildings or the instances per point on the instances per point. So I can randomize the points at the beginning here by using a scale instances, for example, I think, and then using a random value with an RGB, which will scale the points to a certain seed. But it's not doing it on the instances after the instances. Would I have to pick the instances to do that? Or do that in the scaling here? Oh, it's per instance on the actual instance node. There we go, answered myself. Okay, so now I have a seed on the buildings. I have a general block seed going on the blocks. I have a general idea for like, I guess you could say, whatever I can put in between the roads, or I can use an actual geometry to drive my blocks to a certain degree. The next thing I need to work on now is basically orientation of the buildings. So now I've got the seed here, which is okay, and seed here. So in fact, let's have some fun. Let's get a collection info node, and we're going to get our instance, the city block instance, and we're going to use that as the actual instances for the actual world. So this means this particular node needs to be replaced with this. And yes, the buildings are absolutely massive. And I can't zoom out. Let me just reset the view. Yep, big buildings. So let me just make sure I'm to scale correctly. There we go. That's super good, Halloween. Does Pureware work in a browser? Pureware is a standalone, which you can download for free or for donation. I highly recommend Pureware, especially since you can like hold these over the other view by pressing Alt 1, 2, 3. 3 is transparent, and then Control T will make it transparent to mouse. So when it's transparent to mouse, it means you can click through it. If you hold down Control minus on the number pad and Control plus, you can make it transparent as well. Bogota doesn't have suburban sprawl. For some reason, you get to the edge of the city and then the city stops. There's like buildings, apartment blocks, everything, and then all of a sudden it's paddocks. It just stops. The city stops. It's pretty crazy. And everybody's packed in. There are some areas in the mountains where it feels a bit like this, but even then the houses are piled on top of each other like this. Alright, hey Lech, welcome. Okay, so now we have an issue with these buildings that I have in Painterly. One of them is basically I have to pick the instances, right? And it's instancing the whole entire collection. But I want separate children, one or the other. So you turn on pick instances, and then you separate your children, and that should give you some ability to, but it's still instancing all of them at the same time. All right, so this is a question for you, Aaron or Wettinen. Why? Why is it not just instancing one of the collection?
So you have to pick it from the instance object as well. Have you picked? Yeah.
Yes.
You actually have other objects on the collection. Yeah.
I have multiple in the block instance. So, city block instance. Separate the children. Linked into the instance where I pick the instance. And
it should work.
It should. But it's not. Why isn't it? Is it because of the size? Oh, that's why. It's because of the block size is really small. Okay, cool. Alright, I need more view abilities. Found the problem. Thanks for your patience, guys. I'll give myself 100 kilometers to take a look at. Start at 1. Okay, cool. So now we have my cities. They're really big. And now I have my scaling seed, which is not working anymore now. Oh, that's why. Cool. Let's go back into our painterly view and just see how performance tanks while we're into it. Here it is, more or less. And let's generate. Compile the shader, here we go. So far so good. Maybe we can randomize an attribute to randomize the color a little bit. And we're basically generating a really big city really quickly. Still really tall buildings. So let me just go back to my nodes. And the reason why they're so tall is because of the translation. Turn that off. There we go. Make it a bit smaller, less. Change the seed. There we go. Cool. Okay, so there we go. Basic setup for city blocks that we can design to some degree, except all of the city blocks are identical, not as random seed per city block. So to do that, instance index would have to be randomized. So we're going to change to the integer. There we go. No. Each block is still okay. So here's my next question. Now that we have a building all set up, what would you guys do to randomize each seed of each instance, basically? Or randomize, I guess we could get some randomization with rotation. But for example, if we take a look here, we have one block here and another block here that look very identical. So we need to randomize each single instance, I guess you could say, with a different seed. So to do that, we could either block instance that one grid or have a collection of different grids with different seeds, I guess you could say. Or we could just change different things. So what
if you're doing a building generator, right? Then, oh sorry, like a city generator, at least with geometry nodes, because of, sorry if I'm a bit robotic, but at least with geometry nodes, and then you would add the thing which generates the buildings on those positions, and that way you can like pass forwards the seed per build to randomize stuff. It's a bit of a janky process, and it gets very heavy very quickly, but it could be done.
Well, the buildings are pre-made, so it's not too... I'm not generating the buildings per se. Maybe later. I will just need to change the seed per instance, I guess you could say, of the vertices. Like change the index order of the instance. How would you do that? Index of the instance that's used for each point. This is you only use when pick instances is on. By default, the point index is used. So we need an index, get a value, get math. It's changing all of them. Well, wait, could you explain your technique a bit more? To have a general idea? Whoa. I guess we just brute force it. So I'm going to
I
create.
mean,
Hmm?
You mean to like how you would set up the thing to generate? How are you generating your buildings, or are they modeled?
They are modeled. They have been
Okay.
pre-modeled earlier. Basically, I'm just working on layout right now, just layout tools. So I got my rough artistic idea for designing my layout to however I want with blocks, so I can control where my blocks are, how my blocks are. But now I just need to randomize the blocks a bit more before I start drawing my streets. So I need quite a bit of artistic direction, which I have with my emitter mesh, which is perfectly fine. But now I just need to define each block needs to be unique, I guess you could say. Same with like, I could probably use weights to drive the scale. So each block right now is instancing the same block.
So do you have each block being a grid, which is instanced on each point?
Mm-hmm. So I can define it.
So if you were to realize your grid instance, then it's going to randomize what buildings are instanced on those grids?
So realize the instances of the actual grid that's been instanced?
Yeah, exactly. Because right now it's just going to... Oh no, sorry, after they get instanced. But before the buildings are instanced on them.
Before... Wait, okay, so let me just see if I can think this out in simple layman's terms. So I have... Okay, 1 second. Just move this out of the way. Move that out of the way. So you realize the instance after you've... Okay, so I got random scale here. And so, okay, so this is instancing the grid meshes here, right? Okay. So now that I have my grid meshes, I would have to realize the instance from the grid mesh, right?
Yeah.
Which would be here. But the index remains the same.
Yes. But the grid, the actual layout of each grid, is that not different?
No. The grid is an instance, right? No, it's not.
Yeah.
It was before, 29 instances of grids.
So, because when you instance something on top of another instance, it's going to make all of the instances like exactly identical. So you should have different building layouts per grid.
Bizarre. But nope. Oh man, I thought
Might just mute that realizer node.
It changes the index for sure per grid, but it doesn't change. It doesn't like change the index of all of them. And what? Let's mute the randomization.
I wonder if it's... Wait, go back to your instance node that is instancing the buildings on the grid.
This one.
That one, right? So you've got an input socket for instance index on that node, right?
Right now it is off. It's got nothing there now.
Right. So what happens there is that it will cycle through the indices with each of the things in your collection. So if you just put, like randomize integer,
that's what I needed.
you will still need to keep realizing the grids, because otherwise they're going to be, each one will be identical, unless you want each block to be the same.
Gotcha. Simple things that I need to get into my head. So there we go, now we have a city. Cool. Alright. So that step is done. Let's just add the color to that. We'll call this instance buildings. Thanks, Aaron. Okay, so can you get, do vertices have normals? Is that a question? I have another question. Or only faces have normals? Only faces, that makes sense. So I'd have to get a point instance on faces. Distribute points on faces. So I think I may have crashed this by accident. What is a vertex normal, says Jones. But Aaron says you can transfer normals or capture the attribute or something. That's right. I think I may have crashed this though. The vertex normals are the mean average of the adjacent faces. You have the face normal and then the other face normal, and then you have the 2 points on the edge there. So the two angles from the two faces would define the vertex normal as the average between the two faces. And you just add more faces to that. Yeah, no wonder it was about to crash. I'm going to see if this survives. And it gets normalized to get a magnitude of 1. Okay. $2.1 million instances. Give me a moment as I just reboot the system, yeah? I'll just reboot this. I'll force crash it. Wow, handles 2.1 million instances okay though. I mean, well, if I had a better computer. Okay, so let's see where we're at right now. So we have blocks, which has, the problem is it has no rotation, random scale. Okay, so this is the what's missing as a feature. It has no rotation, no automatic rotation, no user rotation, random scale. Concerning scale, what we do have, we've got scale, we've got a guide mesh, and we've got the building, randomization and index per block, which is nice. What else is missing concerning our block generation? We are missing block generator, a city block generator. So we're missing also, I guess you could say, height, I could say artistic height weight. And we also need, or user height weight. And we also need, I guess you could say, user height weight. Yeah, just user height weight. So these are the things we need to look at. So we've got no user rotation, we'll add that to the system, no automatic rotation. So the automatic rotation is basically a system that we're going to have to get from the grid normal, I guess you could say, and kind of guide it through certain things. So let's see if we can figure that out. And let me just reload my old saved file. Recovering. What did I lose? Okay, go back into the view. Get, there we go. Go back to our nodes. Let it compile the shader and go back into Vertex view. So you get some colors. View. Pop. One. There we go. We got this big city. What we did earlier, the things that we lost, which is was basically a random index. Where we get a random value, change it to integer, plug that into the random index node, realize your instances, so that we have a seed concerning every block. Every block has a different seed. Now the next thing we need to do is basically, based on the mesh here, we've got some blocks or some normals, I guess you could say, or some direction of the vertices, pointing some directions and some pointing other directions. To kind of drive kind of like the flow of the blocks. Right now everything is based on a grid rotation. So we need to figure out a way where we can get the vertex normal and use that to drive the instance rotation as an average based on a certain up axis, I guess you could say. For example, with this particular block here, we have an X pointing slightly that way, that way, and that way, and that way. So that means we'll get an average rotation, which will pull this around a little bit. Meanwhile, this one up here in the top here could have another rotation. We just need two axes, I guess you could say, to kind of drive the rotation. So Aaron, how would you do this? How would you rotate the vertex point of an instance based on getting the normal of a face, for example? Hey Steph, how you doing?
I'm fine, mate. Sorry, you can hear my birds. I'll let me mute myself.
No, the birds are sound
I was
nice.
going to say, Aaron probably uses ETK kit.
Yeah.
You can get it here for $15.
That's right. Translation. There we go. Okay. So we want an align to Euler and node. Euler node. Search. Euler. Rotate Euler. Align to Euler to vector. Which means we can use this to drive our... This is interesting. Okay, so this kind of gives us some control. So now we have a rotation of our faces for some reason, but we can now control its vector, which means we can get a vector. We can get the normal, I guess you could say, as a vector. That's kind of cool. Nice. So we get rotating on the z-axis, which is cool, or we can use another axis like this, which could be the x or y based on the null, but it's not really working. We need a better mesh example. So let's get this fair. And let's just check the messages just in case. Align to oily node. To instance avoidance the face along the contour of the surface. Exactly. That's what we're trying to do. Basically, my theory, I mean, I'm no pro at this. My theory is that I get basically the normal and kind of decide which direction the normal is facing, which is the up vector of the normal. So you have pointing out and pointing north and pointing west, for example. So I'll get like the north normal, kind of use it as the up vector for the Euler to rotate the instance along. Basically, that's the theory. Cross product time, exactly. So you cross product the normals and 0, 0, 1, and then that is the vector of your line Euler to vector, and then pivot is Z. Is that what the align to Euler vector node does, or is that from the ground up? You need to transfer your normals from the base mesh as well, do you think? The base mesh here has normals. I would have to transfer the normals to where? Oof. I think I'm probably winging this too much. So I'm gonna close the stream here and just open up the mic and we can just have fun working around here. So catch you guys later. I'll still be here.